Good morning. Welcome to debugging in Xcode 6. So if you had seen our debugging session last year, you would have noticed our quest to bring more relevant debugging information to your fingertips. This year, we're going to continue with this mission. Oh, before I forget, my colleague reminded me to introduce myself. But my name has not changed from last year, so I'm still Han Ming Ong, and I'm still a debugger UI engineer. So let's briefly look at what we're going to talk about this year. I'm going to talk about a new feature in Xcode 6 that will help you with debugging your use of Grand Central Dispatch, which is GCD. This feature is called queue debugging. Next up, Troy is going to come up and show you an amazing new way to explore and debug your user interface. And then Carrie is going to talk in detail how to integrate the quick look preview into your custom class. I want to set the stage for queue debugging so that we are all on the same page. My apologies if this is a little bit too basic for some of you, but it's important that we get the fundamentals right. So when your application hits a breakpoint, the program pauses. The debugger will go through a process known as unwinding. What it does is it looks at the method that contains your breakpoint and follows the frame pointer back to the call site. In this case, awake from nib. It goes on until it reaches the beginning of the thread. Then it comes back with a series of stack frames known as a backtrace. So a stack frame is an instance of an invocation of your method. Now, backtraces are important because it helps you understand the control flow and the state of your application. So what happens, how does GCD impact backtraces? But first, what is GCD? It is a technology that is introduced 5 or 6 years ago in Snow Leopard timeframe. Since then, it has taken off like wildfire because it is a very natural way to create concurrent responsive application. Basically, you divide your task up into smaller work items called blocks, and then you enqueue the block to a queue using two ways, synchronously or asynchronously. We're going to focus on the latter because it poses a bigger challenge when it comes to debugging. You enqueue asynchronously using the dispatch async API. And then what you're telling the system, the OS, is at some time later, it can dequeue your block and find a worker thread to start executing it. Imagine that you've hit a breakpoint in your block right now. So let's look at the backtrace of thread 16. After the debugger has finished its unwinding, the bottommost frame, frame 9, represents the start of the worker thread, which corresponds to the dequeuing event. So what do you have to do to understand the control flow before the enqueuing event? Well, what I used to do is to find the method that contains the enqueuing event, in this case, cached graph image, paste it in the search navigator, search for all the call sites of it, put breakpoints there, relaunch the application, go through all the crazy UI gestures to make sure I can repeat the same problem to hit the breakpoint. And heaven forbids if those call sites are also in another dispatch async, because that means I have to wash, rinse, and repeat. But Xcode is not lying to you when it's giving you this limited backtrace. That's because the thread that does the enqueuing did it asynchronously in the past. In fact, that thread is possibly doing something completely different or maybe gone from memory. So it's not fair to accuse the debugger of not being able to unwind into the past. But in your head, you must be thinking, well, this is accurate, but surely Xcode can present a more logical backtrace. And we agree with you. So in the scenario that I described earlier, we're going to splice in, Xcode 6 is going to splice in the backtrace of the enqueuing event so that it can show them to you in a more logical manner in the UI. And if you have more than one enqueuing events, xcode is going to follow the chain so that it shows you everything. So how do we do that? Well, we work through several layers of the OS down to the core OS, which records all the backtraces of the enqueuing events. So when your application hits a breakpoint, xcode will ask the debugger to retrieve the backtrace so that we can show them to you in the UI. The live stack frames, they have colored icons. The recorded stack frames, they have gray icons. But just like the live stack frame, you can select it, and if xcode has its debug symbols, it will show you the source code, like in this case. If it doesn't have debug symbol, it will show you disassembly that some among us can actually decipher. So why are the icons gray? Well, a recorded stack frame's icon is gray because it is a visual cue to let you know that it's historical. And because it doesn't exist in memory anymore, you cannot interact with it in the console. You cannot run expressions like PO. And xcode will not show you its frame variables because recording the frame variables would cause your application to bloat up in memory, possibly causing it to be jettisoned on the device. So that wraps up the first part of Q debugging. Moving on to the second part. Xcode by default shows you the backtraces in the threads view in the debug navigator. As you can see here, thread 5 is showing you its backtrace. So that just means that the backtraces are organized by its parent threads. There's another equally interesting view known as queues view in the debug navigator. And if you pay attention to your top right corner, there's a little control known as the process view option selector. It is a mouthful, but it is useful. So if you toggle it to the queues view, xcode switches you over to emphasize the relationship between blocks and queues. So in this slide here, you see that the top queue has one executing block. So what about the blocks that you have enqueued but not executing yet? Let's look at this scenario. So I'm using a serial queue as an illustration, but this happens with concurrent queues as well. The green square is your currently executing block. As long as it has not finished executing, blocks that you submit subsequently to the queue will get stacked up behind it. We call these gray squares the pending blocks. So in xcode 6, we're going to show you the pending blocks as well of a queue. So in this case, we have 9 pending blocks. The pending blocks are like the executing block in that if you twist it down, it will show you its backtrace, which by definition is a recorded backtrace of the enqueuing event. So we hope that by surfacing this information, you can answer questions like, how many pending blocks have I submitted to the queue? Am I oversaturating the queue? And if you have literally tens and thousands of blocks, pending blocks, are there some that are not needed? Because you may be able to change your algorithm or your granularity so that you do less work. Now, doing less work is important because that will mean saving battery life on your customers' devices. So on top of that, it will help us solve a class of programming problems that I'm going to go into a demonstration now. So running on the simulator is an application called Jogger, which helps you track your runs in San Francisco and keep fit while you're during this WWDC. Well, I know developers jogging and keeping fit, but we can all dream. Now, I have a timer here that tracks your time and your velocity and a map of all the routes that I've done. And I've done exactly 1 this year, which is 1 too many for me. If you click on the date, if you select the date, it will slide in the detail page of my velocity graph. So notice that it takes a little bit of time to slide in the detail page. And I'm sure you have learned from Apple and your customers that they want your animation to be smooth. Smooth like butter. So this is not. And I want to figure out why. So since I know the code pretty well, I'm just going to jump straight into Xcode to the class known as GraphView. GraphView is the class that draws the graph. And I'm going to jump straight to awake from nib by going to the implementation field of the jump bar and start typing awake. There you go. And I have a method here that creates my velocity path. And I know that is doing a lot of heavy-duty work. So let's jump in to the definition by doing a command click on it. What I see here is it's spending time fetching the velocity data from the database, and then it takes a lock to protect it, and subsequently goes through each data point in the velocity data to draw the path. And when it's done, it releases the lock. So it's doing all this work on the main thread, so it's impeding the detail page from sliding in. And this looks like a good candidate to use a dispatch async. So let's do that. Going back to awake from nib, and I'm going to paste in a chunk of code, which I don't have, but it's all right. All right, I'm going to move the line that creates the path into the dispatch async block. And I'm going to dispatch the block to a simple queue of the graph. And when I'm done calculating the path, I will update it on the main thread like usual. So this is a pretty simple change. Let's rerun by clicking on the run button to see if it works. Okay, I'm going to go to the date so that I can select it. So this time when I select the date, the detail page should slide in very quickly, which it does. But my graph is not drawing. So there are many ways you can try to figure out what is the problem, but one of my favorite ways is to look at the state of the application. And to do that, I will look at the backtraces of the application by clicking the pause button in the debug bar. And I know that work for my graph is done on the graph serial queue, so I found a thread, which is thread 22. I'm going to twist it open. And you may not be able to see at the back, but frame 2 shows that I'm trying to wait for a lock. It looks like it. I'm going to select frame 3 to confirm it. And indeed, I'm waiting for the lock. So those of us who have faced this situation before have a pretty standard following path step, which is to find a thread that has the lock. So let's do that. I'm going to show you a nifty way to show all the backtraces, which is to first collapse the process item, and by holding down the Option key, you can twist it open. So now I'm going to visually just scan through to look for the thread that has the lock. Well, this is interesting because besides the thread 22, which is trying to acquire the lock, I cannot find a thread that has the lock. So this is a head scratcher. But what do you know? We just learned something that may be able to help us. So I'm going to switch over to queue debugging by going to the that control. And here I'm going to use the filter bar to focus on my graph serial queue. So there it is. So it says here I have one running block, which is the block waiting for the lock. And I have one pending block. To show my pending block, I'm going to go to my debug menu item, debug workflow, and turn on always show pending blocks in queues. All right, out pops my pending block. I'm going to twist it open and select the first frame, which has my source code. So plot acceleration curve is a method which I enhanced this morning as well to use dispatch async so that I can do work off the main thread. And it looks like in my haste, what I did is I acquired a lock before I did the dispatch async. So what's going on is this. I have an execution block waiting for a lock. And stacked right after it is my pending block, which unfortunately has the lock. So the pending block cannot move because it has to wait for the execution block to finish. So this is a kind of a deadlock, albeit in a non-classical way. So thankfully, the solution is pretty simple. I just have to move the line that does the locking closer to the place where it's protecting its data, which is velocity data. This ensures that it doesn't try to get the lock until it's dequeued and start executing. So with this second round of simple change, let's see if this works. OK, let's get to the point where I can select the date again. And voila, everything looks correct now. So without this queue debugging, what I would have to do is to search for all the places where my velocity data lock is used and visually look at them and reason really hard about how it's used. And that's error-prone and tedious. In summary, you're going to get queue debugging in xcode 6, which has two parts. Record a backtrace is going to show you backtrace of the enqueuing event when you're using dispatch async, and pending blocks. Hopefully, by surfacing this information, you can optimize your use of GCD. With that, let me bring up Troy to talk about view debugging.
Hi, my name is Troy, and thank you for coming to our debugging in xcode 6. As you may know, xcode is a fantastic tool for discovering things about your application that may be hidden through the debugger. Hanming just showed us two new features through the pending blocks and recorded stack traces that are hidden pieces of information about your application that xcode exposes to you. But we all know that not all of the bugs in our applications are hidden. Some of them are extremely visible. They're staring us right in the face from the user interface of our applications. And since these are visual bugs, wouldn't it be great if we could debug them visually as well? And now in xcode 6, you can. So what kind of bugs am I talking about? These are the bugs where you have a mispositioned view or clipping is wrong. These are the squished or the stretched views. And these are the views that are missing entirely because the visibility or isHidden attribute is set incorrectly in your application. But that's not all that this new aspect of the debugger in xcode helps with. You can use it when you're not even debugging. Let's say I have an application like this, and I would like to add a new button down here. And I don't know, maybe it's new code base to me, maybe it's been a while since I've read this. I don't know what this view is behind it. Wouldn't it be great if I could just click with the mouse and find out what that view is? Well, now you can. This view debugger feature is integrated all throughout xcode. So let's take a look at the xcode window and figure out where the different pieces are so that we know what we're talking about when we're talking about this view debugging feature. Here's the xcode window that we all know and love. When your application is running, down at the bottom, there's the debug bar. This is where you find your familiar items, such as the pause and continue buttons. Well, now there's a new button in here, which is the debug view hierarchy button right here. Simply click this, and xcode is going to import the user interface of your application into the main editor window of xcode. But it's not just imported as a static image. It's imported as separate pieces so that xcode can actually explode it out into 3 dimensions and rotate it around if you want. Seeing your application in this 3D view is very illuminating. It allows you to traverse the hierarchy, see what the parent views are, see what the siblings are. But if you want a more concrete representation of your view hierarchy, we turn to the debug navigator. This is, as Han-Ming talked about, the place where you find your threads and your queues. And that's available here in this process view options selector. If you select the view option in there, now there's threads, queues, and views, down below we have your view hierarchy in the application, which is right here. Down below we have some filtering options to help you tame that list. We have the show only primary views, and we have a show only displayed views. Let me stop on this second one, because this one's important. If you have a view that's missing in your application, it may be that the is hidden is set on it. And so Xcode is also going to hide it in the Xcode UI, but Xcode knows about it. It could show it to you. So you can simply turn off this option, and Xcode will show all of your views, even the ones that are hidden. Finally, there's the string comparison there, which will do an exact match of that list in the navigator to help you drill down to exactly the item you're looking for. Now let's turn our attention over to the right-hand side of the Xcode window. This is the inspector area, and you might be familiar with this if you've ever used Interface Builder, because these are very similar. We have an object inspector, and there's a size inspector as well. Here we see the object inspector for a UI image view. And not only that, this is a specific UI image view, because we're clicking on one that's in our application, so we actually have the address of that object as well, which is resident in memory on your Mac or on your iOS device. We have the thumbnail and all the other interesting attributes about that view listed in this inspector. Finally, we have the size inspector. This is going to show you the size and position, as you might expect. It's also going to show a list of the auto layout constraints that are affecting that view, with two exceptions. Down at the bottom, you see two constraints which are de-emphasized. These are not affecting the layout of your view currently, but they're still attached to the view, and they still have meaning. In this case, we have a self.width of 320, and in the parentheses, you see that's content size. That's because the system added this implicitly to this view to represent the content size. They're de-emphasized because up above, they're redundant with two explicit constraints that were added in Interface Builder, and those also have a width of 320 in this case, but they might not always match. So this is a great place to check if you think you're having constraint issues, as we're going to see in a demo, which I'd like to show you right now. All right, here we have the application that Han-Ming started with. And if you have super eagle eyes, or maybe not, you'll notice that there's a pretty bad visual bug down here. I wonder if the view debugging in Xcode can help us find that. So I'm going to switch over to Xcode, find this debug view hierarchy button, and simply press it. What's happening now is Xcode's going through all of the views in the application and pulling them back into the Xcode window. Now we see the user interface right here. And already you're getting a better look at what might be the issue in this application. You see some of the views, some of the images in this UI collection view are outside the view where they are supposed to be contained. That's a pretty interesting fact to help diagnose the problem, but it doesn't help us solve the problem, so we're going to have to dig deeper. To explode the view hierarchy of your application, all you need to do is simply click and drag anywhere in the canvas. This allows us to see the parent-child relationships between some of these views. I have open on the right-hand side the assistant editor, which is in automatic mode. This allows Xcode to track the file that I click over here in the view debugger with a source code file that matches with it. So if I click here, I get the source code file for UI image view. I'm going to traverse backwards up the hierarchy until I get to the custom cell that has been written for this class. The parent of this UI image view is a UI view, and this is the content view of that cell. And the one behind that is the run details collection view cell, which is custom code in my application. I'm also going to open up the inspector here and check out some of the positions of these views, because it looks like there's probably a position bug here. So traversing back up the stack, starting with one of these views that has a missing image, I'm going to click here and see that the position is 160.45. Its child is 45.45 because the position is relative to its parent. But where is this final view? I'm going to go over to the navigator and find the view I have selected is this UI view, and I can simply find where its child is. I don't know where it is in spatial space, but I know where it is in the real hierarchy of the view. So if I click here, I see that the position is 160.45, and remember that's based on the parent. So what I'm actually looking at is this view over here. I thought that was a working one, but the view has been shifted off of the cell, and that's the reason it's missing. So let's go back up to the cell class and take a look at the implementation of that class. I'm going to command-click on the class name here to dive into the implementation. And here you see a fairly simple implementation for a cell view. All it does is it overrides the initWithFrame, it creates a new UI image view, and then it adds it as a subview of the content view right down here. Thinking about the information we found earlier, we know there's a position issue, and I can see that we're passing the frame rect of the cell to this subview. That's not what I want. I want the subview to have the same bounds as the cell. So instead of frame rect, I'm going to type self.bounds. This should be enough to fix our problem, so I'm going to build and run. Switch over to the simulator. And dive back into our run details view. Sure enough, we have the fully functioning UI collection view with all our images tightly spaced as expected. Now that that bug's fixed, I do see another issue. You see, this label up here, San Fran, is kind of a cheeky nickname for San Francisco, but this is a serious running app. This is an app for those of us that go every morning, and we don't call this fair city San Fran. This is San Francisco. So let's go back to the view debugger and see if we can understand what might be going on there. I'm going to take a moment to admire the fully functioning UI collection view. It looks great. I'm going to then turn back to two-dimensional mode. This button down here allows us to reset the view hierarchy. And I'm going to click on this label. All right, I know that I'm using auto layout in this application, so let's go ahead and see if there's anything having to do with constraints that might be an issue. Down here is the Show Constraints button. This shows all the constraints, and it also dims out the views that are not currently related to that view or its constraints. This allows us to really focus in on the work at hand. When I zoom in, it's plain to see that there are two constraints attached to this label. And if I look over here, I see the width is 95. There's an explicit constraint of 95. But down at the bottom, the content size is 109.5. So clearly, somebody added an explicit constraint in Interface Builder, and that's clipping the implicit size of that label. So I'm just going to switch over to my storyboard, find that label, and delete that explicit constraint. If I had the time to show you guys, I would add a constraint that properly limited that label so it didn't go beyond the bounds of the screen. But I'm sure you can find an Interface Builder session, for example, this afternoon at 3:15, that will go into more detail about auto layout constraints. And then we have the full string of that label. So we've seen that the view debugger is a fantastic way to take a look at your application. And I invite you to do just that. Go back today, just after the session, open up your computers, and just try hitting the view debugger button on your application. I think you'll find it illuminating, and the integration with Xcode is fantastic. Now I'd like to turn it over to Carrie, who's going to teach you a little bit more about quick look previews.
Thank you, Troy. My name is Carrie, and how is everyone enjoying the conference so far? It's great. I know that we are very excited to be here as well to show some great new debugging features in Xcode 6. But first, let's take a step back. Last year, Xcode 5 debuted with this great new feature whereby, as you are running and debugging your application, you can get a live quick look preview of your data. So simply by clicking on the quick look icon in the debug bar, you can get this pop over that would show you a preview. You could even, simply by hovering over the source of a variable in the source editor, get a quick look preview right from there, just by clicking on the quick look icon in the popover that appears. Now, Xcode 5 debuted with default support for a number of important and common object types, like images and Bezier paths, and even things like map locations. Well, we've gotten a lot of great feedback from this feature, and I know that it's been very useful to a number of developers, including myself. So to build on the success, in Xcode 6, there is support for two new object types. The first is views. So whether it be a UI view or an NS view, you can get a quick look preview of that simply by clicking in the variables view and clicking on the quick look icon, or my favorite is just hit the space bar and it'll bring up a nice preview. And considering how common views are in most applications, I think this will be a very powerful feature. Now, the second object type that was added is, well, I honestly don't know. That's because it's your own custom class. So now, for the first time, if you have a class that does some custom drawing and perhaps returns an image or a Bezier path or something like that, you can now get a preview of that as well. Before now, there wasn't great support for that. So if you were to try and get a preview, you would get this default view, which had some pertinent information like the name and the address and the type, but no preview. So I would like to show you how to fix that. There's a simple method that you can implement in your class's implementation, and it's called debug quick look object. Now, in this class, you can either call your drawing code or implement it in there, but the important point is, from this method, you return something that Xcode knows how to show. So one of the default supported types should be returned from this method, and then you'll be good to go. And I would like to show you that now. So here we have the jogger application that we've been seeing in previous demos. And I'm going to click the routes button. And we'll see Hanming's run from this morning, if that's indeed the case. OK, so this class has an object class called route path overlay, which accesses the run data to generate this Bezier path that then gets overlaid onto the map. So let's look at that a little further. I'm going to click on the map, and I'm going to hit this. Whoa, scrolls really fast. I'm going to hit this breakpoint. And let's say I'm trying to debug some issue here. Now, down in the variables view, we can see we've got a number of local variables, like this point. And if I click on the quick look icon, I can see a preview of the point. This is our route path overlay. And if I click on that, I'm going to hit the space bar. And what it just comes up with is just some generic information. But we can do better than that. So I'm going to stop here. I'm going to go to our route path overlay. And I've got the method that I was talking about, debug quick look object. It's a sort of a long title, but try and remember. OK, and if I uncomment that, what this method does, it's not really important because it's going to be different for every custom class. But what it does is it accesses each of the 364 some odd points of map location for that run, and then generates a Bezier path. scales it a little bit, and then returns from it a Bezier path, because Xcode 6 knows how to render or quick look preview a Bezier path. So now that we've implemented that or enabled it, I'm going to run and debug again. And we'll go to our routes. And we'll click on the map. And if all goes well, we should see a nice detailed preview of each of those points of data from the start until the ambulance picked up Han Ming when he collapsed. Okay. So what have we seen today? We've seen Han Ming show us how we can very easily and more effectively debug queues and blocks with the new queue debugging feature. And then Troy showed us how we can more effectively or easily explore our application's view hierarchy. I've used this very effectively myself several times. It's been very helpful. And then I showed you how to add quick look previews for your own custom classes. And remember, you can also now preview any view. So for more information, you can contact our great developer tools evangelist, Dave DeLong. I've also got a link here to the documentation for quick look previews, which documentation will show you a full list of exactly all of the default supported types in Xcode 6. And then don't forget the developer forums. There's a lot of great debugging sessions this week, so be sure to check them out. Thank you very much.